Yeah, so thank you for coming to this talk today. I am Gene, and Cheng is also going to give a demo later on in this presentation. And we will be here talking about the best practices of using Alluxio with Spark. And we are both software engineers at Alluxio. So here's a brief outline of the talk. I'll first go over a brief overview of Alluxio to explain what Alluxio is and where it fits in the ecosystem. I will then go into some real-world use cases of organizations using Alluxio and Spark together. I'll then go into how Alluxio and Spark do work together and how Alluxio can help Spark in different use cases. And then I'll go through a simple performance evaluation of different scenarios. And then lastly, Cheng will give a demo of Spark and Alluxio working together. So before we get started with Alluxio, I'll first want to talk about how the big data ecosystem used to look like. And maybe 10, 15 years ago, it was actually quite simple. We had the Hadoop ecosystem. We had Hadoop MapReduce for the computation, and we had Hadoop HDFS for the storage. And they were both co-located with each other, and this model was very effective. However, the data ecosystem doesn't look like that anymore. It actually looks more like this, where we have a lot more computation frameworks and application frameworks like Hadoop, Spark, Flink, Presto, et cetera. And we also have a lot more storage systems out there. HDFS is clearly still very popular, but there's other new storage systems out there, such as the cloud storage like S3 and Google Cloud and Azure, as well as other on-premise type of solutions, such as from IBM and HP and EMC. So there are a lot of different storage systems and a lot of different application frameworks, and it can actually get quite messy in trying to integrate and operate between all of these. It's also difficult to manage all these different connections, possibly. So it can get actually pretty difficult to add and remove different storage systems or different computation frameworks. And in addition to that, some of these storage systems are inherently remote from the computation. So you can actually incur some performance degradation by going into this type of model. So this is where Alluxio comes in. And so Alluxio is this storage layer between the existing storage and the computation application frameworks. And Alluxio provides this unified namespace and API for applications to use. And then you can essentially mount different storage systems that you may have into the Alluxio namespace. And this allows apps only have to talk to one storage system, which is Alluxio, but it's being backed by different storage that you may have, such as HDFS or S3 or Google Cloud. And so this makes it really easy to add new applications as well as add new storage systems in your environment. And this also really makes it easy to disaggregate the computation layer from the storage layer. You can actually keep them separate now. You can scale them independently. You can manage them independently, and that can provide other types of benefits. And in addition to providing this convenient layer, Alluxio also caches hot data, important data in memory close to the application. So it can provide the performance benefits that you get by co-locating storage with computation, but not having to be co-located with all the storage that you may have. So Alluxio provides both the performance with the in-memory data as well as the convenience with the unified namespace. And so this sort of new next-gen analytics platform so Alluxio can help new types of applications. You can have new applications running on all the different types of data that you have, and we've seen it in different types of use cases, such as big data or IoT, machine learning, deep learning, things like that. And so we've seen a lot of different applications for this type of stack. And just also to talk more about Alluxio, Alluxio is an open source project. It actually was born from the AMP lab at UC Berkeley. And it's the same lab that that Spark came out of and Mesos came out of. So this is it has a rich history in terms of the open source community. It's actually also one of the faster growing open source projects out there in the big data ecosystem. Here is a graph of the number of contributors on GitHub. And Alluxio is actually the top line. And this is sort of in the first N number of months that it's been open sourced. Alluxio was open sourced about 4 years ago. So it's about 45, 48 months ago. And as you can see, Alluxio has, I think it's exceeding like 400, 500 contributors now on GitHub. So it's been really exciting to see the growth of the project as well as how people are using it and trying it out in their production environments. So next I'll go into how different organizations use Alluxio with Spark in their environments. This first case I'll talk about is from Barclays. And they have a machine learning use case where they have Spark jobs trying to do some machine learning training, and they're trying to read the data from Teradata. And this actually, every time a new training session needs to be kicked off, it would actually have to load all the data from Teradata repeatedly each time. And that actually took a long time in their case. It took, I think, 30 minutes to over an hour in some cases. So you would have to do a lot of waiting to get these jobs up and running. So instead, they actually put Alluxio in between Spark and Teradata, and they would only have to load the data once into Alluxio. And then after that, the different Spark jobs, the different training jobs that would have to be run, they would just read it directly from Alluxio and not have to load it again from Teradata. And this, and in Alluxio, the data was all in memory. So the I/O costs were greatly reduced, and so the Spark jobs could actually start much quicker instead of having to wait for the loading to happen. So this is one case where they could greatly accelerate their jobs by sometimes hours by storing it in Alluxio and putting Alluxio in their ecosystem. The next example I have is from Baidu, which is one of the largest search engine companies out there. And in their existing system, they had Spark SQL, and they had their Baidu file system, which is similar to HDFS. And in their situation, their file system was actually remote from the computation cluster. So all the data access would actually have to go over the wide area network. And so in order to improve that, they actually put Alluxio in that system. And Alluxio was co-located with the compute cluster, which is the Spark cluster. And so because Alluxio could keep the data in memory and close to the computation, it was much faster to do the Spark SQL computations. And these are sort of data analysts running on a lot of the data. So I think they could get, some queries were up to 30 times faster because they could keep the data in Alluxio and not have to repeatedly go out to the remote file system. The next example I will talk about is from Qunar, which is like a travel website in China. And in their use case was pretty interesting. They have multiple computation frameworks. So they have both Spark and Flink. And they have multiple storage systems like Ceph and HDFS. And so it was sort of being difficult to manage, and the performance wasn't great. And so they put Alluxio on their computation side of things. And the Alluxio could actually provide this unified namespace for both of their storage systems so that applications could transparently access the data through Alluxio and not have to worry about where the data was from. And also, it could keep the data close to the computation, keep the hot data close. And so I think the queries, I think it varied from like 15 to 300 times X improvement. And the reason it was such a high improvement was that some of the storage systems were actually remote, and so when there was a lot of traffic in the system, the bandwidth was being limited by all the traffic. So by reducing the amount of traffic, Alluxio could provide higher gains, performance gains for them. And this last example is from Guardant Health. They're doing genomics and cancer research, and so they actually have a lot of data, and so they actually wanted to move to sort of like a cloud S3 type of storage. And so they chose Minio for their storage to be able to scale out to lots of data. But that is a remote storage system. So they added Alluxio to their stack so that they could be able to cache a lot of the important data closer to the Spark cluster, and so that it would speed up a lot of their queries by orders of magnitude. So yeah, so these are sort of a few of the use cases that are out there that are using Spark and Alluxio together in their environments. So next I'll talk about how Spark and Alluxio do work together to benefit the user. So one example of how Alluxio can help Spark is by being able to consolidate memory. So when you have sort of multiple Spark jobs going in the cluster, and they might be on the same machine, and if they're looking at the same data and they want to cache the same data, you might be duplicating the data in memory in both of those Spark contexts. So in this example, we have sort of two jobs that want to read the same data, and so both blocks 1 and 3 are duplicated in both of these Spark contexts. And so they've both been, so that you're using twice as much memory as you potentially had to do. So if we add Alluxio in the picture, so now the storage can be essentially offloaded to Alluxio. And by keeping the storage in Alluxio, the different Spark computation contexts do not have to store it in their memory anymore, and they can actually just access it directly from the Alluxio managed memory. And in that case, the blocks do not have to be duplicated, and Spark and the different Spark jobs can actually read and write the data directly from memory without having to duplicate that data. And so this is an easy way of, well, first of all, the memory usage has been consolidated, and on top of that, this is an easy way to essentially share data between jobs through the Alluxio memory. Another way that Alluxio can help with with Spark jobs is essentially data resiliency with the crash. And so with Spark, unfortunately, there might be some bugs, or maybe there's some out-of-memory errors or something like that. And so if a Spark job crashes, it actually it will wipe out the storage as well. And so now the next time you want to run that job, it will have to read it from the existing storage system, or read it from disk, or maybe from network, and it could slow down the job. So with Alluxio, it's essentially independent from the Spark job or jobs. So when the Spark job crashes, the data is still resident in the memory of Alluxio. So the next time a job has to access that data, they can directly read it from the Alluxio memory, and it'll essentially be just as fast as it was when the job wasn't crashing. So this is another way of how Alluxio can help with help with Spark jobs. So next I'll talk about how you actually use Alluxio and Spark together. And so there are basically two things you can do with data. You can either read it or write it. And so to write data to Alluxio, Alluxio provides a file system interface and a file system API. So it's very simple to write data. You would just write to an Alluxio file. And in the same way, it's really easy to read data from Spark. You read from an Alluxio file. So I'll then go into some examples of what that looks like. So in the RDD APIs, if you want to write an RDD to Alluxio, you can do RDD save as text file or save as object file, and you can write it into Alluxio path, and the rest will just happen. And then for reading, it's the same thing. You point to the path in Alluxio, and you can either read as text file or read as object file, and you can load it into an RDD. In the same way, in the DataFrame API, you can do the same thing. And so to write, you would write, so in this case, we're writing in the Parquet format. You can write to an Alluxio path in that way, or you can read from Alluxio path in that way. So it's actually very simple to integrate with the existing Spark jobs, and sometimes you may not even need a code change, just changing a path to the job. So it's pretty simple to integrate with integrate Spark and Alluxio. So next, I will talk about sort of a small, simple experiments that we've done with Alluxio and with Spark. And so this is essentially the setup that we had. We ran this on several months ago, so Spark 2.0 and Alluxio 1.2. And we used a single AWS instance. And we essentially wanted to see how does Alluxio behave in different scenarios compared to some of the cache levels of Spark. So in this first example, we call it reading a cached RDD. What this means is that the RDD is already cached in Spark or already cached in Alluxio. So the data is already there in memory or in the cache, and we want to sort of reread that data to see how long that takes. And so here is sort of the time it takes for different sizes of RDDs. And well, so the top green line is actually I think the cache disk, the disk line. So clearly that's going to be slower than any of the memory caching. So that's why it's so slow. But what this shows is that for smaller sizes of data, so when the data is smaller, the Spark cache in memory outperforms Alluxio. But as the data grows larger and larger, Alluxio, so the Spark performance, the cache performance decreases. What? Well, I guess PowerPoint crashed. Sorry about that. So at a certain point, Alluxio, the Alluxio caches, or the reading from Alluxio, reading from Alluxio essentially scales linearly. As you can see, as the RDD size grows, the slope essentially is a constant. And one thing to note is that the blue line, which is Alluxio text file, is faster than the red line, which is Alluxio object file. And that's because reading from a text file has less serialization and deserialization involved. But not all RDDs can be represented as text files. So that's sort of one thing to consider. So this is sort of our experiments with the RDD. Next, we did a similar experiment with a 50 gigabyte RDD, but this RDD was actually in S3, and we were sort of simulating what happens when you have to create a new Spark context or a new Spark job. So this is a new context experiment where we want to read that RDD from S3 using a new context. And so obviously with no Alluxio, Spark would have to read it from S3 again, and so it takes almost 800 seconds. But with Alluxio, it takes closer to 100 or fewer seconds. And so with Alluxio, when it's already cached in Alluxio, even though you're in different contexts, you can read it from the memory just as fast as before. And so you can cut down the I/O costs a lot, considerably. We did similar tests or similar experiments with the DataFrame API, and it's actually the similar results as well. With the smaller dataset sizes, the Spark cache outperforms Alluxio, but as the dataset sizes grow, the Alluxio scales linearly. And so one thing to note is that this is, I think, for all these systems, we use sort of like the default out-of-the-box parameters. So I'm sure you could probably tune the parameters to provide better performance. But so these were all sort of done with the default settings. And so then the last set of experiments that we did was the new context of a data frame where the data frame is living, the 50 gigabyte data frame is living in S3. And so this shows similar results where, obviously with Alluxio, you can read it much faster because it's already cached in Alluxio locally close to Spark. So it's about, on average, 10 times faster. But another thing to notice is that S3 inherently has a lot of variability. And so I think, we ran the test essentially 7 times. And if you see the red bar, that's the range of completion times that we saw. And so it ranges by over like 1,000 seconds, I think. So you can see a huge variance between the runs by always having to go to S3. But if you have the data already in Alluxio, you don't have to go to S3 as often. And so the variance is much smaller. And so the Alluxio red, it may not even be easy to see, but it's only maybe about like 10 seconds or so in terms of the difference. So it also reduces the unpredictability of the network. So next, Cheng will come up and give a short demo.
Thank you, Jing. So since the PowerPoint crashed before, I hope my demo won't crash. Can anyone see clearly the text? Or should I make it larger? Is this OK? OK. OK? OK. So in this demo, I will illustrate how Alluxio can accelerate remote file access in Spark. We will do this by starting a Spark job for counting the lines of a file stored in Amazon S3. And so in the PowerPoint, we have a slide to demonstrate the environment I've set up. OK, so in my local machine, I have set up a Spark cluster and an Alluxio cluster. And then I used the Amazon S3 bucket as the understorage of the Alluxio cluster. And now let's see what the contents are in the S3 bucket. As you can see, the S3 bucket just holds some files of different sizes. And now, let's verify that the Alluxio file system holds this data too by running the Alluxio share command ls. So Alluxio knows that the S3 bucket holds these files, but note that these files are marked as not in memory, which means that only the metadata are in Alluxio now, but not all the real data. So now let's start a Spark shell for running the counting lines job. OK, first let's set the log label into info, so that we can see how long it takes to finish the job. And then let's read the data from Alluxio. And so this is the Alluxio path you see in previous Jing's presentation. It just begins with comparing to the HDFS parse. It just changes from HDFS to Alluxio. And this 50 megabytes text file represents the 50 megabytes text file in the Amazon S3. And then we do the count. Since the data is not in Alluxio now, the first stage of the job is to fetch the data from the remote S3 bucket. So depending on the network condition, it may take a lot of time. But in this case, it should just take like 30 seconds, I think. So when we are waiting for this, I'll make the point of this demo. That is, when the data is read from the S3 bucket, it is cached in the local Alluxio cluster. So further on of the same job will not fetch the data from the remote S3 bucket again, so it will be faster. OK, so the job finishes with 43 seconds. Remember this number, and we'll compare to it later. So now, let's verify that the data is really in Alluxio's memory now by running the same ls command. You can see that for the 50 megabytes text, it is in memory now. So if we rerun the job again, then the file will be read directly from the local Alluxio cluster. It doesn't need to be fetched from the remote S3 bucket. So it will be finished very quickly because the counting lines job is not a difficult one. Yeah, so it just finishes in 0.3 seconds. Remember that previously it takes 42 or 43 seconds. So that is the performance boost. And consider that if you are a data analyst, and after finishing this job, you close your Spark shell, or if you are running a Spark job that takes a lot of time and the Spark shell just crashes during your running, let's simulate that by closing the Spark shell. And then later on, for whatever reason, you want to run the job again. So you start the Spark shell again. As before, let's set the log level first. And then run the same job. Since the data is still in Alluxio now, although the Spark shell crashes, or even the Spark processes crashes for itself too, the data can be read directly from the Alluxio cluster, so the job should be finished very quickly too. Let's verify that. So it takes just 1.4 seconds. Comparing to the first run, when the data is not in Alluxio, it takes 42 seconds, and that is the point. Yeah, so that is demo. Thank you.
Thanks for the demo. And so, so just in conclusion, we talked about how Alluxio is used with Spark and how it can help, how you can read and write data to and from it, and also how you can be able to connect to various different types of storage systems. So that is the end of our talk, and I just want to thank you for listening.
Awesome. And if anyone has questions, feel free to come up to one of these two microphones and ask away.
Hi. The question is, how does Alluxio handle the situation when underlying data source has changed externally?
Could you say that again?
Yeah, so imagine S3 data source has changed externally by some third-party job, but the data in Alluxio will be not in sync with the underlying data source.
Yeah, so that's a good question. So if you modify data that Alluxio already knows about, if you like delete it and re-upload it or something, then there will be an inconsistency. But if you add new data, like say you add a new directory or a new set of files, then Alluxio can actually pick that up transparently.
Thank you. And how the data is evicted from Alluxio when there is high memory usage? So when there is no memory in Alluxio to store more data, what happens?
So Alluxio has a tiered storage feature where you can store it in memory as well as other storage media if you choose to, and also there's an eviction policy that you can configure to sort of manage how that data gets moved around.
All right, thank you.
Thanks.
Hi, my question is about what's the task locality of your job if I'm reading from Alluxio? Would I have tasks like node local or rack local awareness?
Yeah, so Alluxio will provide the information to Spark or to any framework where the data is, so you can get node local access to the data.
Quick question here. So in modern analytics use case, you would usually use some Calmer data format like Parquet, where you wouldn't need all the dimension for certain queries. So does Alluxio support not caching the whole file, but some hot blocks your job usually would read from it? So say some few dimensions out of the whole 100 dimensions in a file, in Parquet file.
So Alluxio is a file system API, so it will it essentially breaks up a file into multiple blocks, and each block will be cached or not cached in different tiers independently. So there's no, it's not, Alluxio will not look into the Parquet data, but it will break it up into chunks or blocks.
Awesome. That's all the time we have for questions right now. If you have more questions, feel free to come up and talk to the presenters afterwards. But let's give them one final round of applause.
Thanks.